Hello everyone, let's do an example on Limacon with an inner loop. So, as you can see, this is form 4. This is a Limacon. The graph is a Limacon. And since A over B, 1/4 is less than 1, then the graph is a Limacon with an inner loop. Okay, let's now proceed to checking if there is symmetry. So, test for symmetries. Let's start with checking if there is symmetry with respect to x-axis. So here we retain r, replace theta with negative theta. So let me copy first the given. It's r equal to 1 plus 4 sine of theta. So r is equal to 1 plus 4 sine of negative theta, which can be simplified as 1 minus 4 sine of theta. As you can see, the resulting equation is not equivalent to the given. Therefore, the test fails to show symmetry with respect to x-axis. Let's check symmetry with respect to y-axis. So to do this test, we retain r and replace theta by pi minus theta. Let's start with the given. R equal to 1 plus 4 sine of theta. Retain r. Replace theta by pi minus theta. And the sign of a difference, we get sine, cos, cos, sine. Distribute the angles. We have pi, theta, pi, theta. Since this is a minus, then I should have a minus here. And we know that sine of pi is negative 1. Oh, sorry. Sine of pi is 0, and cosine of pi is negative 1. So simplifying, I get r equal to 1 plus a minus times negative 1 is positive. So that's positive 4 sine of theta. And this is exactly the given. Therefore, we can conclude that the graph has symmetry with respect to y-axis. And finally, let's check the third symmetry with respect to the origin. So, what we're going to do here, retain r, theta replaced by pi plus theta. So, copying the equation, we have r equal to 1 plus 4 sine of theta. Retain r. Replace theta by pi plus theta. And then sine of a sum, we have sine pi, cosine theta. It's plus, so I'll have a plus cosine pi sine of theta. This is 0. This is negative 1. So r here is 1 minus 1 minus, because of negative 1, minus 4 sine theta. This is not equivalent to the original equation. Therefore, the test fails to show symmetry with respect to the origin. So we only have one symmetry, that's with respect to y-axis, meaning we can consider, it's enough for us to consider points from negative pi over 2 to pi over 2. Then, copy that to the left of the y-axis. So, let's do that. So, we have, let me note that here, symmetry with respect to y-axis. So, our theta, we can have negative pi over 2, pi over negative pi over 3, negative pi over 4, negative pi over 6, and 0. Then pi over 6, then pi over 4, pi over 3, and pi over 2. After that, we take the sine of theta, and then multiply sine theta by 4. So that's 4 sine of theta. And lastly, solve for r, 1 plus the 4 sine of theta. R is 1 plus 4 sine of theta. Okay, let's do that. Sine of negative pi over 2, negative 1. Sine of negative square root of 3 is negative square root of 3 over 2. So this is negative square root of 2. This is negative 1/2. Sine of 0 is 0. Sine of pi over 6 is positive 1/2. This is positive square root of 2 over 2. Square root of 3 over 2, and sine of pi over 2 is 1. Next, we multiply sine theta by 4. So 4 times the value here. So this is negative 4, negative 2 square root of 3, negative 2 square root of 2, negative 2, 0, 2, 2 square root of 2, then 2 square root of 3, and 4. Take note that square root of 3 is approximately 1.7 and square root of 2 is approximately equal to 1.4. Is that so? Yeah. So now we find r. 1 plus 4 sine theta. So 1 plus the values here. Okay. So we have 1 plus negative 4. So this is negative 3. Here, this is approximately equal to 2 times 1.7. So 3.4. Negative 3.4. So 1 plus negative 3.4. So that's negative 2.4. And here, this is approximately equal to negative 2.8. Right? Negative 2.8. So, this will be 1 plus this one is negative 1.8. Then, 1 plus negative 2 is negative 1. This is 1. Right? This is 3. This is approximately equal to 2.8. And this is 3.4. So adding that, I have 3.8 and 4.4, and this is 5. I think we are now ready to plot our points. And remember that there is symmetry with respect to y-axis. So this is negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6, 0, pi over 6, pi over 4, pi over 3, and pi over 2. Let's start with negative pi over 2, negative 3. So that is 1, 2, 3. This is 1, 2, 3, 4, 5. Next, at negative, let's use red. At negative pi over 3, we have negative 2.4. So opposite to that is 2 pi over 3. I have negative 2.4. 1, 2.4 somewhere here. And since there is symmetry with respect to x-axis, so I also have a point here. Next, negative pi over 4. Negative pi over 4 is over here. It's negative 1.8. So opposite to that, which is 3 pi over 4, I should have a point negative 1.8. So 1.8 here. And that should also be here, since there is symmetry with respect to x-axis. Next, negative pi over 6, negative 1. Negative pi over 6, negative 1, so over here. And a reflection over here. That's it. Then 0, 1. Angle 0 and 1. And I also have a 1 here. 0, 1. Oh, sige, let's see. Okay, next. Pi over 6. Pi over 6, 3. So, 1, 2, 3. So, I should also have a point 1, 2, 3. Here. Is this a 3? Yeah, this is 3. Then, pi over 4, 3.8. Pi over 4, 3.8. So, I have a 3.8 here. Pi over 3, 4.4. So, this is 4.4. And a reflection here. Then, what do we have? Okay. Next, lastly, pi over 2, 5. Okay, so let's join our points. Take note, this is a Limacon with an inner loop. Let's have blue. Limacon with an inner loop. So we have this. If we solve for pi over 2, then we'll have a better view of the graph. And our inner loop is this one here. It's this part here. Sorry about that. There you go. Okay, so this is a Limacon with an inner loop. Okay, that's it. Good night.